Hi everyone. Today's video is on the concept of what is called a radian measure. Now a radian, and I'm going to go ahead and write this down, a radian is another way to measure an angle of any kind. Now, how do we measure angles now? We measure them in degrees. But there are some instances, especially in calculus, where the radian comes out to be easier. So let's talk about what a radian actually is. So the first thing I'm going to do is I'm going to draw a circle. And fortunately my tool makes it into a perfect circle, okay? Now, what a radian is a way to measure not only an angle, but it measures the arc of an angle. So in geometry, and I'm not sure if you guys have heard this before, when you have an angle that is 90 degrees, like this one, this arc, this piece of this circle, can be measured in inches, yards, etc., but it also can be measured in degrees. This is also considered a 90-degree arc, no matter how big the radius of your circle is. So the circumference of a circle is one big giant arc. It's 360 degrees, okay? So 90-degree angle means 90-degree arc. 20-degree angle means 20-degree arc. Now, and that means that I don't care how big or small your circle is, the arc and the angle are the same measure. Now, what a radian is an angle that is formed by the radius of the circle. So I'm still fixing my circle here. So let's say my radius is that long. I don't have a ruler. I don't know exactly how long that is. But I want to know if I took this here and I laid a piece of string on it, and if I was in class I would do this in front of you. If I laid a piece of string on that and then I put my string from here up the circle this way, how far would it go? It would go about probably right there. This blue line and this red arc are almost the same size. The angle that you see here is 1 radian, because it is made by a radius of a circle. Now, a radian happens to be about 57 degrees, a little bit more than 57 degrees. Now, the interesting thing is this. If you take this radian and you make more of them, and you continue around the circle, go to here, and then go to here, it takes approximately 3 plus a little bit more to get halfway around the circle. It takes about 3 of these plus a little bit more, 3 radians plus a little more equals halfway around the circle. Okay? Now, in terms of degrees, how far is halfway around the circle? 1/2 of a circle in degrees, like I was just talking about, would be 180 degrees. Because remember, 90 degrees was straight up and down, 180 is all the way around. But in radians, it happens to be 3 plus a little bit more. In actuality, it's 3.14159 blah, 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 which is what unit? What is that? That is pi. So, this tells us a big known fact. 180 degrees is the same thing as pi radians. And that is how we convert from one to the other. The object of this lesson is to teach you how to convert between degrees and radians. So, to go from degrees to radians, you are going to multiply by pi over 180 degrees. Well, why are you allowed to do that? You are allowed to do that because up here we wrote down that 180 and pi are equal to each other. So when you multiply by pi over 180, you're multiplying by 1 and just changing the way that it looks. Okay? So this here is very, very important. And you would put that on your formulas page for the assessment. Now to go the other way, radians to degrees, you would multiply by 180 degrees over pi. Now, how do you know if your angle that they're giving you is in degrees or if it's in radians? The way you know is this. Degrees have the degree symbol, this little circle up there. You've seen that many, many times. That is how you know an angle is in degrees. Radian angles have no unit of measure. I wrote the word radians here, but in reality, they would just put pi and not put the word radians. So if you see an angle and it doesn't say degrees, assume that it is radians. So let's do an example of each one of these. I'm going to change colors to make it stand out. First example, I am going to take 120 degrees and change it to radians. Okay, so all you do is you take the angle and you multiply it by pi over 180 degrees. So to finish this problem, you are going to just simplify this. Now, are you going to put the pi in the calculator? No, 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 no. Do not do that. What you're going to do is you're going to take the 120 and the 180 and you're going to divide them because this is really 120 over 1. So you take your calculator and you type in 120 divided by 180. And if it gives you a fraction answer, that's even better. And it happens to be 2/3. So this is 2/3 pi, or you can write it as 2 pi over 3. Put the pi on top. Now, what if your calculator doesn't give you a fraction answer? What you need to do, this is a different way to do it. So you will take your problem here, you will write it as 120 over 180 pi, and you're going to reduce that fraction. Well, how do you reduce 120 over 180? Well, they both have a 0, so I can mark those out. So I get 12 over 18 pi. All right, so now I go, what else can I divide both 12 and 18 by? 2 works, 3 works, but go as big as you possibly can. The biggest thing that works is 6. So you divide both 12 and 18 by 6, and you get 2 over 3 pi, which is the same answer that I got above. So you can do it with your calculator, or you can do it the way I did it at the bottom. This is by reducing fractions. All right, let's do a radians to degrees problem. You are going to have, let's say we have 7 pi over 6 to degrees. What is that going to be in degrees? Okay, the rule says we're going to multiply 7 pi over 6 by 180 degrees. Whoops, I started writing pi. Over pi. Now this one is a lot easier. Okay, so what happens to the pi's here? They cross out, they cancel. So what you're going to have is 7 times 180 on top, which is 1260, divided by 6, and you just do the math on that, and it comes out to a nice big number, which is 210, and that is degrees. Please make sure you label the answer as degrees. Now notice over here that I didn't put any sort of label on that answer. I didn't need to, because I just said before, radians don't get labels. However, degree answers must be labeled as degrees. All right, that is the gist of this lesson. If you will go this time to the online book page, for this lesson out of the Theta book. So go to the 2.4 webpage There is a link there for page 189, exercises 12.01. They have copied the pages there. You need to do those problems, and the answers are also on the link that links to the book. So this is 12.01. It's on the Middle Maths page. So from this point on for a while, all of your assignments are going to be on the 2.4 Middle Maths page. I'm not going to be linking any worksheets because the book work is just as good. Please make note when it says so. They have whether it's basic or extension. If it says extension, that is for excellence work. If it says basics, and if all you want is achieved, you need to do the basics question. But if you want merit or excellence, you need to do the extension questions. Good luck with this homework, and let me know if you have any questions.